All right, so your reverse of chain rule is called U substitution. U substitution can be used in this example, okay? But U substitution is typically used in something like example 2, where I have an inside function and I have something on the outside that's being multiplied by it. Okay, and my hope is that what I'm multiplying by on the outside eventually cancels out. So that's the goal. So I have an inside function, and when I do something to that inside function, it would cancel out the x on the other side. Okay, not all of them look like this. You don't actually, like, the reality is that if you get enough of these, you don't actually have to do the U substitution. You don't actually have to do that whole process. You can look at it and be able to figure it out. We do this one only because it's easier to do a U substitution. It requires less thinking and less effort. Because you can automatically realize that there is an inside function of 2x minus 1. Okay, so your first step is to let u be equal to the inside function, which is 2x minus 1. Step 2 is going to be to take the derivative of 2x minus 1 implicitly. So that would mean the du over dx is equal to 2. Step 3 is to solve for dx. So that means I'm going to have to move dx to the right-hand side. And then divide both sides by 2. So I get dx is du over 2. Step 4 is to do substitution. So I'm going to plug in my u in for my 2x minus 1. And instead of dx, I'm going to write du over 2. Questions so far? Gonna rearrange it slightly so that 2 in the denominator makes a 1/2. And then I have my square root of u as u to the 1/2. And then I have du. So now, step 5, take the integral, or the antiderivative, whatever you want to call it. So I have my 1/2. I add 1 to the exponent, multiply by the reciprocal, and add a plus c. So I get 1/3 u to the 3/2 plus c. And then I resubstitute what u was back into the equation. So I put u back in, which is 2x minus 1. And that's it. Yes, no. Du turns into plus c.
Oh.
It's like dx. Yes, Jack. Because dx and du represent the change in that variable, which is the initial condition.
So is that why we take the
No, the plus c gives you the change in the constant.
No, like with the taking the derivative of u in
It's so that I can substitute everything in here, so that everything is in terms of u and not x anymore. Uh-huh.
So like in the original equation, it was taking it all with respect to dx, right?
Correct.
Dx. Now we're taking it with respect to u.
Correct. Other questions? Let's do another one. Always let u be equal to the inside function. So u is equal to x squared plus 1. Now, instead of writing du over dx, I already know I have to move that dx to the right-hand side. So I don't have to. I can skip this step here of du over dx, and I can kind of just jump right into du is equal to 2dx instead. Skip a step. So when I take my derivative, my du is 2x dx. Then it makes solving for dx a little bit easier. And then I'm going to substitute it in. So I had an x. I have the squared. What's inside is u. My dx becomes du over 2x. So then what you notice is that the x's cancel out, which is great because you can't have x and u mixed in together. The idea with u substitution is you get rid of all of your x's, and all you're left with is u's and du. Yes?
What if we were put in a situation where we didn't cancel out?
I'll show you. That's the last one. So I'm going to rewrite 1/2 u squared du. Other questions so far? Are we okay? So I have my 1/2. I have a u cubed and a 1/3 and a plus c. So I get 1/6 u cubed plus c. And then I resubstitute my u back in. And I have my plus c. Yes, no.
So you only use the substitution when there's an inside and outside.
Correct.
function, and just like the change.
Yeah, anytime you have an inside function, you're going to use it. Yes.
Where did the 1/2 come from?
The 2 in the denominator. Yes, Alex.
So, example of the substitution question be like numerical multiplication.
No. No, because your u that you let u be equal to should have a derivative relationship with what you're trying to cancel out. So here in this case, my u has an x squared plus 1, and when I take my derivative, I'm left with an x. The only exception to that is the last question. But other than that, and even then, even with this, I could have multiplied it out and then done it. But the reason why you wouldn't have done it with today's question is because when I let u be equal to x minus 2, it does not cancel out the x squared. And what I'm about to do in the last example doesn't get rid of the x squared. Other questions that you guys have? Okay, so sometimes your inside function is masked a little bit, and sometimes it looks like you have a double inside function, which in this case you kind of do. But for the most part, when you have a double inside function, you don't have to do the u substitution twice, because you'll eventually cancel everything out that's going to be an issue. Okay, so I rewrote this so that you would see that my inside function is sine of 3x. So then du is equal to cosine of 3x times 3 so then dx is equal to du over 3 cosine of 3x. And then step 4 is to do substitution. So I substitute in my u and my dx. And this is what I'm talking about. I don't need to do a double u substitution because that cosine of 3x is going to cancel out. So then I'm left with the 1/3 u squared du. Hard part about this is that you do so many steps that you forget to take an antiderivative. So I have my 1/3. I have a u cubed multiplied by 1/3 and a plus c. So I get 1/9 u cubed plus c. And I replug u back in. So it's 1/9 sine cubed 3x plus c. To go back more to Alex's question about like when to use it. Ultimately, what you're trying to do is you're trying to reduce what's inside the integral to something where you could do the reverse of power rule. Or you can take the antiderivative of sine. Or you could take the antiderivative of 1 over x. That you've reduced it and simplified it enough to a very low level question. And I'll show you here in this last example, because you might think, man, did I do this wrong? Is there something I could have done differently? And you really do have to use u substitution in this case. Whereas in that case, with the x minus 3 cubed over x squared, there is something else that you could have done to make it less messy. And if you were to try to do it this way, using this example, you'd make it messier than what you wanted to deal with. Okay, so like if I look here, and this is what Nahal was talking about like it doesn't cancel out, right? So I'm going to let u be equal to my inside function. That's always the rule. Let u be equal to the inside. When I take my derivative, du is equal to 3 dx. So then dx is du over 3. When I go to substitute in, that's where my problem ends up being. So I have my u, and then I have a du over 3, but that stupid x on the outside never went away. Stupid x. So I will go through and I'll clean it up just a little bit. So I have 1/3 x u to the 1/2 du. So I still have this little problem of x. This requires a little bit of effort. To get rid of that x, I need to take the fact that u is equal to 3x minus 1, and I need to solve for x. So add 1 to both sides. U plus 1 is equal to 3x. Divide both sides by 3. So x is equal to u plus 1 over 3. Now I can go back up and say that this is 1/3 u plus 1 over 3 u to the 1/2 du. And now I got rid of all my x's. Now I have as much u's and a du. questions so far? We take a deep breath. I have a 1/9 u to the 1/2 times a u plus 1. All I did is I just rearranged them around a little bit. Don't want to lose anybody, taking some baby steps. But now we gotta distribute. So I have 1/9 u to the 3/2 plus 1/9 u to the 1/2 and a du. This is what I'm talking about. You've done so much work right now. You may have forgotten you have actually not taken an antiderivative yet. And then on a multiple guess test, that answer's there. With or without the u's. It could have been x's, it could have just been u's, right? And then you're like, and they just dropped the integral sign and they called it a day, right? And then you messed yourself up. So now I need to take an antiderivative. Even took me all the way over here to get to step 5. So I have a 1/9 u to the 5/2, so that's a 2/5 that goes in front, plus a 1/9 u to the 3/2, so a 2/3 goes in front, and then a plus c. Lots of effort. So a 2/45 u to the 5/2, just kidding, plus 2/27 u to the 3/2, and then a plus c. We're finally at the last step of plugging u back in. 3x minus 1 to the 5/2 plus 2/27, 3x minus 1 to the 3/2, and a plus c. And I will spare you the factoring out fractional exponents for now. Because you technically could. Yes. Oh, it should be a 45. Other questions?